Hello everybody and welcome back to another RevWise video. Today we're going to be looking at a fundamental IGCSE chemistry topic, being atomic structure. I'm going to go through all key definitions and important things you need to remember for this unit. I'm also going to go through a few examples of questions and calculation techniques that you can use for questions revolving atomic structure. So let's go straight into it. Okay, let's start off with two key definitions that we need to remember. Now first off, the definition of an atom. An atom can be defined as the smallest unit of an element that retains the chemical properties of that element. Each atom consists of a nucleus containing protons and neutrons surrounded by electrons in various energy levels. Now the part that I've highlighted is the part that you need to remember for your IGCSE definition if you are asked, what is an atom? The rest of it is additional information that may help you with your understanding, but it's just there for you to have a comprehensive understanding of what an atom actually is. Now, on the other hand, a molecule is a group of two or more atoms chemically bonded together, forming an identifiable unit which retains the properties and composition of the substance. This is the definition that you will need to remember for your IGCSE exams. Now, molecules can consist of the same types of atoms as in O2, which contains two oxygens, or different types as in water, which is H2O, two hydrogens and one oxygen. Next up, let's talk about subatomic particles. Every atom is made of components called subatomic particles, which are called protons, neutrons, and electrons. Now, these subatomic particles have specific relative masses and charges that are unique to each subatomic particle. This table outlines that. We can see that a proton has a relative mass of 1 and a relative charge of +1. A neutron, on the other hand, has a relative mass of 1 but a neutral charge of 0. Now, an electron has a negative charge of -1, but its relative mass, as stated there, is 1 over 1,840. Now, for IGCSE, we can count this as negligible. So you are to say that the electron has a negligible mass, so therefore you do not include this mass when you're doing calculations of an atom's mass, as this mass is so small that we can simply discount it. Alright, now that we have an understanding of subatomic particles, we can get into some more definitions. Now I know it looks like quite a lot, but this is actually quite basic, and once you understand it, it will be a breeze. So first let's look at atomic number. The atomic number of an element is the number of protons in the nucleus of an atom of that element. It is denoted by the symbol Z. The atomic number uniquely identifies an element and determines its position on the periodic table. Next up, let's have a look at mass number. The mass number is represented by the letter A, and it is defined as the total number of protons and neutrons in an atom's nucleus. Now, unlike the atomic number, the mass number is not a fixed characteristic of an atom. This means that the same atom can have a different mass number as the number of neutrons can vary. And going on this, let's define an isotope. See, isotopes are atoms of the same element that have the same number of protons but different number of neutrons. For example, carbon-12 and carbon-14 are isotopes of carbon. Both have 6 protons as they are both carbon, but carbon-12 has 6 neutrons, whereas carbon-14 has 8 neutrons. It's very important that we remember this definition of isotopes, as it appears very frequently on IGCSE examinations, and the definition is actually quite specific. Just to remember it, the first few words are very important. Isotopes are atoms of the same element. Once you have that, it's pretty easy to get the rest of the definition. So, yeah, try and remember that. Alright, now that we've got those definitions out of the way, we can move on to an actual exam technique, which is finding the number of protons, neutrons, and electrons in an element. The best way for me to show you this is by an example, and that's why I'm going to use copper, as seen in the top right. I included the picture of copper as it appears in the periodic table, as this is how you will see the elements in your periodic table during your exam. So first, let's figure out how to find the number of protons, which is very, very easy. In fact, it requires no calculation at all. This is because the atomic number of an element directly tells us the number of protons in the nucleus of the atom. For copper, the atomic number is 29, which we can see in the top left. Therefore, a copper atom has 29 protons. Okay, now let's figure out how to find the number of electrons. Now, this is very easy as well, because in a neutral atom, the number of electrons always equals the number of protons. This is because the positive charge of the proton is balanced by the negative charge of the electrons. So for a neutral copper atom, it has 29 protons, therefore it also has 29 electrons. Now this would be impacted accordingly if you have an ion that has a positive charge or negative charge, which would require more electrons or more protons. And you will probably explore this in when you're doing past paper questions by yourself. Finally, we have to figure out how to find out the number of neutrons, which is the only one which requires somewhat of a calculation. Now, the way we figure out the number of neutrons is by looking at the mass number. See, the mass number of an atom is the sum of its protons and neutrons. To find the number of neutrons, we need to subtract the number of protons from the mass number. For copper, we have a mass number of 63. So, to figure the number of neutrons, we need to do mass number minus protons. And this means 63 minus 29, as we calculated the number of protons earlier. And that gives us a neutron number of 34. So, a copper atom with a mass number of 63 has 34 neutrons. Alright, now that we've done all the easy parts, it's time we move on to something slightly more challenging. What is relative atomic mass? Well, to understand this, we first need to understand why we need relative atomic mass. See, atoms are so small that we can't actually compare their masses in conventional units, such as kilograms or grams. So therefore, we need to use a unit called relative atomic mass instead. Another reason we use it is because, as we discussed earlier, atoms exist in multiple isotopes, which each have different mass numbers. Therefore, in order to come up with this, an average, we need to consider every isotope and its abundance when coming up with an average for the mass of the atom, and therefore we use relative atomic mass. What we can understand in relative atomic mass is that it is the quote-unquote average mass of all the different types of an element's atoms compared to 1/12 of the mass of a carbon-12 atom. Essentially, one relative atomic mass unit is equal to 1/12 of the mass of a carbon-12 atom. For example, hydrogen has a relative atomic mass of 1, meaning that 12 atoms of hydrogen would have exactly the same mass as 1 atom of carbon-12. All the other elements are measured relative to the mass of a carbon-12 atom. And since these are ratios, the relative atomic masses have no units. And this is very important to understand, that when you're doing a calculation with relative atomic mass, there's not going to be any units. Now, when an exam question asks you to define relative atomic mass, it's important you remember this following definition. The relative atomic mass is the weighted average mass of one atom of an element, taking into account the abundance of all isotopes of that element. It is measured as a ratio of 1/12 of the mass of an atom of carbon-12. It's quite a long definition, but remembering it will certainly help you in your exam, and as long as you understand it, I'm sure you can synthesize your own definition as well. Alright, now that we understand what relative atomic mass is, let's figure out how to calculate it. Now, the way we calculate it is by using the formula seen on the top of the page. Relative atomic mass equals the percentage of isotope A times percentage of mass of isotope A plus the percentage of isotope B times the mass of isotope B, all over 100. Now, this formula only uses isotope A and isotope B. However, it also works with further isotopes. So you can add an isotope C and isotope D, however many you are provided, and the formula will still work out to deliver you the relative atomic mass. Now, this formula is pretty easy to remember, and all you have to do is plug in the values you're given in the question. So let's look at the table. This table gives us the mass numbers and percentage abundances of 3 different isotopes of an element. It wants us to calculate the relative atomic mass of this element. So how do we do this? Well, we just plug it into the formula. Let's call the mass number 24 isotope A, the mass number 25 isotope B, and mass number 26 isotope C, which is not seen in the equation. We just plug it in, and we do 24 times 79.2, which is the abundance, 25 times 10, and 26 times 10.8, and we are just adding them together. Keep in mind that for the percentage abundance, you just have to multiply it as it is. You don't need to do anything to the percentage. Now, you just do that all over 100, and we get our relative atomic mass of 24.316. As you can see, it's very simple. We just have to plug into that initial formula, and as long as we know that formula, we're able to calculate relative atomic mass with ease. And that's it. I hope you enjoyed the video. If you have any further questions, please let me know. I will upload depending on your request, so if you want a specific unit in biology or chemistry or whatever subject you need, just let me know in the comments or however you want to let me know, and I will respond to you as quickly as possible. And yeah, hope you enjoyed the video, and see you guys in the next one.